Hi everyone, and welcome to exploring the Stream Chat Android SDK. My name is Martin Brown. I'm a developer advocate and engineer on the Android team here at Stream. I'm also a Google developer expert for Kotlin and Android, and I love doing community stuff. So I'm a university lecturer. I run my own Kotlin course there. I also contribute to Stack Overflow, as well as a bunch of different open source projects, including my own. And of course, I now get to do open source as my day job at Stream, which is especially awesome. In case you haven't heard of us yet, here at Stream, we provide chat as a service. So this means that we take care of creating the hard parts of a chat experience so that you can focus on building out the rest of your app. There are a lot of considerations to make when you're building chat. You have to have infrastructure in place. You have to make sure that it's reliable and always available. You have to take care of scaling to many, many users, messages, and interactions. You have to pay attention to security and compliance with local regulations and all of that. Again, we take care of all of this for you. We provide this as a service, and we give you client-side SDKs so that you can easily integrate with our backend services on whatever platform you're on. In case you need more than our client-side SDKs, you can also integrate on the server side easily with our REST APIs so that you can ship custom experiences. For example, you can send automated system messages when you have events happening in your own application, or you can query the data in our chat instances and act based on that. Today is going to be all about Android for me, so I want to show you what our Android client-side SDK can do and what it looks like. We, of course, have first-class support for native Android applications, and we ship three main packages that you might integrate into your app. We have a low-level client, which takes care of just the networking calls. So this is a typed wrapper around our APIs that you can use. Then we have a offline library, which wraps the client and provides offline caching and offline operations on top of it. So for example, you can send messages while you don't have a network connection available, and whenever the network comes back, those messages will be sent for you automatically. And then finally, we also have UI components, which again build upon the offline library. The offline library ships view models and live data so that you can easily build UI on top of it. And our own UI components integrate with our offline library so that you don't have to write the chat interface yourself either. All of this, as you'll see soon, is open source and available on GitHub. Here's our agenda for today. First, I'm going to give you a quick tour of our GitHub repo. Then I want to show you the basic concepts and mechanisms of Stream Chat by taking a look at how the low-level chat client works on Android. Then I'll show you how quick and easy it is to set up a brand new blank project with our SDK and display some basic pieces of Chat UI. And finally, we'll look at some more advanced features in our full sample app, which again is available open source. This is the GitHub repository of our Android client-side SDK for Stream Chat. As you can see, all of our development is happening out in the open here, and we are very happy about our SDK being open source. We even participate in things like Hacktoberfest, as you can see from the tags on the right-hand side here. If you scroll down a bit, you'll find all of the modules that contain the code of our Android SDK implementation. You can freely browse these at any point and look at the implementation details should you need to do that. If we go further down, we'll find the README file for the SDK. Here, you'll find useful links for getting started with Stream Chat. So for example, for registering a new API key, you'll find the links to our tutorial, both Kotlin and Java, as well as our written and our generated documentation. There's also links here to the sample app, to our UI kit, and a lot more. So this is a great starting point. If we scroll back up, you'll see here on the right-hand side that most of our SDK is written in Kotlin. We're only writing new code in Kotlin at this point, but we still support both Kotlin and Java clients. So even if you're still using Java, we are aiming to provide a neat API for you so that you can easily integrate our UI components. But we do recommend that you use Kotlin now. Then coming further back up, you'll see that all of our releases are here on GitHub as well. So if we go into releases here, you'll see each of our releases that has been published. You can also use this to check what the latest version of our SDK is. And each release comes with detailed change logs for each of the different modules that we publish, so that you can keep up with what's being fixed and what new features we're adding. Moving on a bit, here on the top, you'll find the Issues tab, which is a great way of getting in touch with the development team directly. Here we address questions and bugs and feature requests fairly quickly. So again, this is probably the best way of reaching the development team. You'll also see that we are closing a lot of these issues very quickly. So for example, here are some issues from last week where someone found attribute that wasn't being parsed correctly. And after this was reported, you can see it being assigned and a pull request for a fix being opened in a matter of a couple hours. And then it made it into a release a couple days later. So you can expect this kind of iteration speed for minor bugs, so that your development is not held up by any potential problems in our SDK. You can also see all of our pull requests here out in the open. This is not something you generally have to keep track of, but it's interesting to see that we are developing at a rapid pace. So we are improving and updating the SDK very frequently. There is a very active team working on this. Finally, if you want to find your way back to this repository later on, for example, to check the latest version and so on, it's always a good idea to start a repository in the upper right-hand corner here. Now, let's take a look at how you can get started with the low-level client SDK on Android. As you can see, I have a very simple project here where I have an empty screen so far, and I have this long method set up so that I can print some data on the screen. When you register for Stream Chat, you're going to get an API key. So I'm going to start by declaring that as a variable here. And then I will create a chat client. So I'll create an instance of chat client for which I will use a builder. And I have to pass in the API key that I've just declared, as well as the application context to this builder. If you want to configure things like file uploads to your own server, or the log levels, or notification settings, you can configure all of that on this builder instance. For now, I'll just use all defaults and build it. This client offers a lot of different operations that are global operations within the SDK. So you can see here that we have basic methods like connecting the user, subscribing for events. Going further down, we'll find creating new channels, enabling things like slow mode, flagging messages and users, grabbing messages, muting users, sending files, images, events, and so on and so on. So basically all global functionality is available through this client. What you want to do after creating a client is connect a user most of the time. So that's what I'm going to do. For the user, I'm going to use my own user here. I already have this created on the backend, so I'll just paste the ID that I already know. This ID can be an arbitrary string. Otherwise, this is up to you about how you want to create your users. A user object can have a bunch of different properties that I could fill out, but most interestingly, it can have a extra data field, which is just arbitrary key value pairs. I'll use this to set the name of my user. I'll set that to my own name, but you could add in any data here. So let's say that you have your own IDs for users in your own application and you want to reference that here. You could have those ID values thrown in here, or just any custom data that you want to associate with the user, basically. Other than specifying the user when you connect, you will want to specify a token as well. Ordinarily, you would do this by implementing the token provider interface, which gives you the opportunity to grab a new token whenever the previous token expires from your own backend. You would be generating these server side. But again, for the purposes of this demo, I'll just use a single hard-coded token, which has my user ID in it somewhere and doesn't expire. So that's going to be my login. And when you call things in our SDK, most often they don't immediately execute the operation. If we look at connect user, we'll see that it returns a call object. And when you have a call, you can choose how to run it to actually perform the operation. We could run it with execute, but for the demo, I'm doing this in the main activity on create, so this would block the UI thread. Or I can do it asynchronously, which I can do with the enqueue method. This will give me a result, and when this result comes back, I can check whether this result was a success. And if it was, I can log the data that was in the response, for example, the connection ID in there. And then otherwise, I'll just log that some kind of error has happened on the other branch. I can build and run this application now, and we'll see if we've managed to successfully log in. And yes, we have a connection ID printed right there. So this is all good. This means that on this branch, we are now logged in and we could perform additional operations here. But if we kept doing this, as you can see, we would keep going in and in with the code, deeper and deeper nested to the right. So I'm going to stop using this callback-based mechanism, and I'll use coroutines instead. This is useful if you already have coroutines in your project. You can run these, for example, in your view model layer, depending on your architecture. For now, I'm just going to keep it simple and run this in the lifecycle scope of the current activity. What this means is that I no longer have to twist my code around for callbacks. I can just await this connection result. Let's actually call this connection result. And after this, I can keep doing my operations down here. I'll also skip all of the error handling here, but please remember that you should be checking whether each response was a success or an error. These are all network operations, so there's always a chance that they can fail, and you should handle that in your own implementation. Okay, so we're logged in now. I'll just to be safe, I'll always log the connection ID so that we can see that on the screen. Up next, we want to grab a channel. And just like we had a chat client for global operations, we can create a channel client for operations specific to our channel. We can do this by calling client.channel and passing in the channel type and the channel ID. For the channel type, I'm going to use messaging. This is the most basic channel type that we have. We also have some other channel types with different default configurations, such as for a live streaming use case. So I'm specifying the channel type, and then I can come up with my own channel ID. Let's say I want to call this channel developer week. So I'll put that in as the ID. This doesn't create the new channel yet. It just gives me a reference to a client that can work on the channel. I can create this channel in a couple different ways, but I'll just use the create method, which does nothing other than making sure that the channel exists. I can pass in some parameters here, including a list of members. So I can grab my own user ID here, and then I will immediately be added to this channel as a member. And just like with users, you can add arbitrary data here in this extra data map. In this case, I'm gonna set a name for the channel, just like I set one for myself, and I'll call it developer week. And again, just like before, I'm gonna await the result of this. And if I assign that to a variable, I'll call this channel. I'll actually grab the data from the response immediately. And so you can see that channel has the type channel, and this has, if I scroll down a bit, this has a bunch of information about the channel, when it was created, who created it, its ID, its members, any pinned messages, the type, if there are teams associated with it, and so on. I want to log something here so that we can see that the channel was created successfully. I'll log the channel ID, and maybe I'll log the name of the user who created it, which should be my own user. So let's see if running this works as expected. Awesome, you can see that the channel response came back. We can see the channel ID that we've set and that I was the person who created the channel. Okay, with the channel ready, we can now send our first message. For messages, we have a message object, and again, this has a lot of parameters that we could fill out. A trivial message would be something like hello world, and we can send this by just calling channel.sendMessage, channel client.sendMessage, and passing in the message object to it, and we can again await the result. So this can be called message result. And to see that we've succeeded, I'll grab the data from message result and I'll log the ID of the newly created message. That seems like a good enough check for now. If I build and run again, we'll see a connection ID, the channel still being created, and then these 2 lines is the very long ID of the newly created message. So all of this is working great. I'm gonna remove this code that sends the message so that we don't keep spamming messages. And for the final thing to try, I'm gonna list some of the messages in the channel, which I'll use again a channel client for. I'll query this channel client, passing in a query channel request, which gives me the current state and info of the channel. But I also want to make sure that there are messages included, which is not the default behavior, because there might be thousands of messages in the channel and you don't want to make network calls for that accidentally. So I'll specify that I want the first 10 messages from this channel. And again, I'll await this result and then grab the data from it. And I can just save this to the channel variable again, because this is a new state for the channel that I already had. And if I now log, let's say, channel.messages.size, or even just all the messages and mapping them each to their text, then we're going to have a view of the messages that are there in the channel. And that's correct. So we see that there's 1 message in the channel, and we can see that it's this hello world message. And if I send another message with the text, hey developer week, I uncomment the code that sends the new message, and I run that again, then we're going to see 2 messages being returned from the query. So you can see that we're slowly starting to populate this channel with data. When it comes to messages, you can also add extra information here. Most importantly, perhaps, you can add attachments to your messages. This is described by the attachment object. Attachments can have some default things like a title, text, an image URL, asset URL, and so on. But again, just like with all other objects around here, you can also add extra data into attachments. So if you need to add your own custom things to attachments, then you can do that. You're just going to have to take care of rendering them on the UI in some way on the client side. Another thing you can add to messages is reactions, which we also have full support for, but we'll take a look at that on the UI later on. Up next, I want to show you how easy it is to get started with our Android client-side SDK, which I'm going to do by setting up some new UI in a brand new fresh Android project. As you can see, I already have this blank starter project running here in an emulator. First, I'm going to go into my project level build.gradle file and add 2 repositories, which we're going to use to pull in our dependencies. Then I'm going to go to the module level build.gradle file, where I'll first enable view binding by adding build features view binding through. And then I'm going to add our Android SDK as a dependency here to the list of dependencies. This is going to be the latest version of our UI components, and I'm going to hit sync now so that these become available within the project. I'm going to create 2 screens here. The first one is going to list the available channels to chat in, and then we're going to navigate to a new screen whenever someone opens a chat and display the actual chat interface. To do this, I'll go into the layout for main activity and I'll replace its contents with the following, where I'm just adding a channel list view from our Android library, and this is going to fill the entire layout of main activity. To set this up, I can go back to the code of the activity itself, and I'm going to replace this with this code. This might seem like a lot of code at first, but it isn't all that much. So here we're just grabbing the layout. We're using view binding for this. That's our preferred way of looking up views. It's also an official recommendation. Then we're setting up the client. You've already seen how to create a chat client earlier on. And now we're initializing the other 2 layers of our library. So we're initializing the chat domain and then the chat UI instance. Then we're connecting with the client, again, something you've seen before. And here's the part where we use the actual client-side UI SDK. We're creating a filter. We're going to be looking for channels which have the type messaging and which have our current user in their list of members. With this filter created, we're going to grab a view model. For this, we need a channel list view model factory, and we're grabbing a channel list view model out of that. If we look at channel list view model, we're going to see that this exposes its current state as a live data, as well as things like typing events. So we could observe these manually using observers. But we can also very quickly and easily bind it with a channel list view, as it's the view model for channel list view, by calling viewModel.bindView and passing in the view instance. This single line connects the view and the view model both ways, so any actions performed on the view will be propagated to the view model, and any state changes in the view model will be displayed in the view. And that's pretty much it. If we now run our application again, we should now see that we are successfully connecting with the client. This view model is initialized, and a list of available channels will be displayed. We're just going to have to run a bit longer while the build completes. And it should be done right about now. There we go. We saw a loading animation, which is built into channel list view, and it has loaded the list of available channels. We can see unread counts and the latest messages everywhere. We can enter a channel. Let's say I want to open this critical depth channel. Well, we can't open it yet because we haven't set up navigation, but we can browse the list of channels. We also have some basic message actions and the message information, or channel actions and channel information here, which we could hook up with listeners and so on. But for now, let's just move on to the next screen. So for this, I'm going to go back to the project view, and I'll create a new activity which will display the chat interface. I'm going to use an empty activity for this. I'll call it channel activity. Everything should be good there. And Studio creates this activity for us. I'll open the layout file and again override this. This time I'm inserting multiple views here, so I have a constraint layout in the root. And then we'll have 3 pieces of UI from our UI SDK here. On the top, we're going to have a message list header view, which will contain general information about the current list. Then we'll have the message list view, the main piece of content that displays messages. And finally, on the bottom of the screen, we're going to have a message input view, which can be used to compose and send new messages. Again, to hook all of this up with view models, we're going to go to the code of channel activity and replace this with some code snippets. And we'll quickly take a look at what we've done here. You'll see very similar things as before. Here, we're just setting the layout. Then we're grabbing the channel ID from an intent parameter so that we know which channel was tapped on the previous screen. Then we're repeating the same pattern as we've seen on the channel list. On the top here, we're grabbing 3 view models for the header, the list, and then the input view on the bottom. And we're using bind view on each of these to bind them to the views in our layout. Again, this will make all of the necessary connections. Finally, we have 3 very quick steps here where we're connecting the different views that we have on the screen. Since you might not have all of these, you have to do some manual plumbing here to get them all hooked up. For example, when someone starts an edit of a message in the list view, then you can notify the message input view that message edit should happen, and it will populate the input field with the current message and things like that. We also have some back navigation here just to make sure that navigating back in different ways when you're inside of a thread works correctly. But this is all the code that we need for this to work. So if we now run the application again, we should be able to tap any channel and navigate to it. Except I forgot to set up the navigation part. So I'm going to go to main activity and replace this listener inside the set channel item click listener method so that it starts the new activity. And I'm going to run this really quickly one more time. Okay, we're logged in. We have a list of channels, and if I click a channel, you can see that our second screen now loads correctly. We have this header up top, which displays the name of the channel and the number of members. We have the message input view on the bottom, where I can compose a new message and send it. And we have the main message list in the middle here. You can see that we have threading, we have reactions. We can, of course, also long tap on messages and interact with them. For example, I can add new reactions like this, or I could long tap this message and open a thread and say, this is a thread here, and send it. And if I navigate back to the channel, you see that this now has a thread reply on it. So those are some basic features, and this is the very quick 8-minute version of creating a brand new project and having working Chat UI in 2 screens. For the last part here, I want to show you the full possible functionality of our Android Chat SDK and our UI components by giving you a very quick tour of our sample app. You'll find this sample app in the UI components sample module of our Android GitHub repo. I have the login screen already open here, so I'll open the app with my own user. You can see that I have a list of channels here. Again, channel titles, recent messages, unread indicators, and so on. I can take a look at my mentions here. So these are people who have mentioned me in chats. I can tap any of these to navigate to that channel and have that message highlighted for me so that I can take a look. You can do something similar with search. You can search for a given word, and you'll find all messages that contain that. And again, you can quickly and easily navigate to these messages. You can start a new chat by tapping on the new chat button on the top right. This can be a group chat or not. I can browse a bunch of different people in here. I can say hi to them. And if I send a message, I seamlessly transition to the chat interface where I can now start chatting with this group. If I tap the button on the top right, it will load the chat info screen for me where I could name this group. I can look at the members, I can look at common files, and so on. Let's go to a channel that already has some content in it. We have this cute pics channel where I've already posted some cat pictures. If I go to the chat info here and I take a look at the available photos, I'll see all of the pictures that have been posted here previously. I can also post some new messages, so let's browse for some new cat pictures. Let's say I want to send these 3 in a message, and I want to say cats while I'm doing that. If I send this message, you'll see a brief upload indicator, and then my new cat pictures will appear in the channel. I can tap on any of these to browse these pictures, and I can also perform some actions in this gallery. If I tap this button on the top, I can choose to reply to this message, to save it, or show it in the chat, or I can also delete an image. So if I tap delete here, it will remove that first picture from my new message and just have the last 2 cat pictures here. I can also delete an entire message. If I long press on it, I can reply, copy, edit, and delete. So I'm going to delete this message, confirm that, and that message is now gone from the channel. And I'm seeing this message deleted placeholder, which others wouldn't be seeing here. There's also support for dark theme and light theme here. So I can disable dark theme. And here we see the light mode of the UI components. I can tap on messages and leave reactions on them. I can tap on them and start new threads, reply to them, copy the text of a message if I want, and also mute or block a given user. So this is the full sample app that you can play around with and get a pretty good idea of what kind of chat experience you can build out using our UI components. That's the end of exploring the Stream Chat Android SDK. Please check out our website where you'll find our newly updated Android chat tutorial, as well as our GitHub repository where you'll find all of the resources that I've shown you earlier, which make it really easy to get started with integrating Stream Chat on Android. If you have any further questions, don't hesitate to ask. You can do that through our website, or you'll also be able to find us on Twitter on the usernames on the bottom of the slide. For now, stay tuned for a Q&A coming up soon, and enjoy the rest of Developer Week. Thank you.